And I'll go ahead and share my screen so you can see what I'm doing. Let me put my big guy here. And there we go. Okay. So what is the prompt?
Oh, I can't see your screen.
Oh, you can't? Oh, shoot. Hold on for 1 second. There we go. Okay.
Yep.
All ready to rock and roll?
Let's do it.
So did he say we do the OIs first or just the pseudocode?
I'm not sure that he said. You could go ahead.
Okay.
We have time if you want to go ahead and do the OIs too.
Okay. So C. This is usually how I do most of my problems anyway, is I do the OIs first and then I pseudocode. So the prompt is, let's see, we're doing rotated array search. So given a sorted array that has been rotated some number of items right or left, how can you efficiently find an element? For simplicity, you can assume there are no duplicate elements in the array, which is why I was like cool using index. Let's see, output is the index of target element in array. The input is an unsorted array and target value. Constraints. Constraints would be array must stay unsorted. And the edge case is return null if, what is it, return null if target is not an array. Okay, so the way I did this is first, let's see, how did I do this? Yeah, so I said if, pardon me, if the index of target is not in the array, return null. And then else return the index of target in the array. That was my simple solution to finding the index of a target element in an unsorted array.
And so you probably the one that you failed was probably the there was one that said must find the target quickly or something like that.
No, the one I failed, for some reason, I failed the one that was the array that said 1, 2, 3, and 5, and it came back with -1 instead of null.
Oh, huh.
Which is what it would normally return. I just said, like on line 7, I specifically said return null if it's not in the array.
Yeah, interesting. Okay, so mine. So I'll share mine.
Okay.
So there was a constraint piece that I was thinking of a little bit differently.
Okay.
Let me find my, here we go. Why is this still open? Okay.
Oh, wow, you went ham on this. Sweet.
Well, so here's why. So I'll put it in here because I'm going to have to reference mine. So, okay. My output should be index of target in array or null if not found. Input is going to be a so this was, I sort of had, I was thinking about this differently than you were in that it's a sorted but rotated array, which is important in the way that I was trying to implement. So everything's going to be in order, but there might be a point at which the array flips from the highest value back to the lowest value and begins again.
Ah.
Constraint. So this was the piece that caused me to make this thing a lot more complex. This target time complexity. So the time complexity, it's basically O log n.
A logarithmic.
Which means basically, if I understand O log n right, the array of potential indices.
That's how I remember how to
must be cut in half at each iteration.
Oh, so they wanted us to find the midpoint, so to speak.
Yeah, so kind of like a binary search.
Okay.
And edge cases, like you, if not found, return null. So, like in a normal binary search, you would do a you would initialize a min index to 0, max to end of array, and then your first guess is equal to your midpoint. And then you would do a, or the way that I've done it in the past is while my min is less than or equal to my max, I'm gonna do something. And then the only tricky part compared to a like typical binary search, I think, is you're gonna check if guess is equal to target. If so, return the guess index. That's no different than a normal binary search on a normal binary search tree. Otherwise, so in a normal binary search, then because you've got a sorted array, if your guess is, if your midpoint is smaller than your target, then you've got to look to the right. Your midpoint is larger than the target, then you've got to look to the left. But in this case, because the array is rotated, it's unclear if you need to look to the right or the left based on just that criteria. So this is where I'm going to struggle to articulate in words what I ended up doing. So I'm going to have to reference my code a little bit here.
It's fine.
So like, how do I know to look to the right or the left? Then I'm going away from pseudocode. This is more like whiteboarding, I guess, but
you're fine. That's why it's practice, not the actual.
Yeah.
Not the actual game.
So if my guess, so what would be what would I need to know that I need to look to the left? Look to left if these things are true. Guess is less than target value, and if guess is less than target value, which means the target would otherwise in a binary search be to the right. And min, see, I'm gonna have to look at my code because I can't say this. I look to. I'm gonna start with look to the right because that's what I did in the code. Look to right if guess is less than target and guess is less than min and min is less than target.
Okay. Oh, wow. Cool.
And why, but see, this is where like as I was coding it out, I could logic through it, but it's so hard for me to put these into words. So I would need an example or a whiteboard probably for this. But anyway, that was my logic. If those three things are true, then I know that my target value is not going to be to the right of the midpoint. It's going to be to the left.
So yeah, so if any of those, so look to the right if all those things are true, else look to the left.
Look to yeah, exactly.
Okay, so you could put that on line 39, say else look to the left. Yeah, there you go.
Look to the left, and then basically just continue the while loop. I think there's I'm skipping some steps here because actually there's basically a look to the right where all these things are true, or guess is greater than target, and all these things are reversed. I'm not gonna put you through the pain of trying to listen to me stumble through that.
No, you're fine. I mean, like I said, we still got plenty of time, and I'm not. It's not bothering me to listen to you talk about your logic and stuff because I think I did the extreme minimal and you did the not extreme maximum, but you did you gave yours significantly more thought. So I'm interested to hear your thought process.
Yeah, I mean, it was basically just that. So maybe the easier way to do that would be with an example, right? Because I'm struggling with this, and that's how I was thinking about it in my head is what would be an example. So if we've got an array where the values are 4, 5, 6, 7, 0, 1, 2, 3. And we're looking for the number let's say we're looking for the number
2.
1.
Oh, okay.
So the midpoint, I did a math.floor, so my midpoint is going to be this 7. So that's going to be my first guess. Now I need to know whether I need to search the right-hand side of 7 or the left. So guess is less than target. No, that's not what I wanted to do. Let me add, because I want to put the example that I just we just did. Let's assume the easy way is just say, let's assume that I had done a math.max and this was my first guess. My guess is 0. I need to know whether to look to the right or the left. So guess is indeed less than my target. It's also less than my min. No, I see. I wrote something out wrong because this, based on this criteria, I wouldn't look to the right. I'll see if.
Oh, yeah, here, look to the right. If guess, oh, that's left, sorry.
Guess value is less than target. Oh, this should be look to the left. The first thing I did was say, what do we do if we look to the left?
Okay.
Otherwise. So let me do that again. So in this scenario that I just defined, I start here, and I'm only going to look to the left if all three of these things are true. Is guess less than target? Yes. Is guess less than min? Is guess less than min? Yes. But the min value is not less than the target. So based on that, I would look to the right. That actually doesn't sound that special, because I would look in a normal binary search, I would look to the right. But what about a scenario where my target value is, how would it look? What would it be a scenario where I'd actually need to look to the left-hand side, even though my target value is, so let's say this started at 1.
Mm-hmm. But it would continue in order, wouldn't it? Like 1, 2, 3, 4, and then 0 would be on the end, maybe.
Yeah, so let's say this started at 2, 3. I think this will work. 4,
okay.
5, 6, 7, 8.
Or maybe 1, 0.
1.
Okay.
So this would be a scenario where it's the opposite of what would normally be true in a sorted binary search case, right? So I'm going to start on 6. To the left. This is why I needed more. This is my other section down here. So if guess is greater than target and guess is greater than max and max is greater than target. Else look to left. So in this case, my guess is greater than my target, which is still 1. My guess is also greater than my max, and my max, oh, that's not a good example either because it's equal to the target. Oh, AC, I'm giving up on trying to explain this one.
But I don't know, I felt like you were pretty close.
The problem is writing an example, because it's actually way easier with an example. I feel like maybe if I had done.
Yeah, you can use examples in pseudocode. I don't see why not. I mean, they want you to try and do it without any actual, but unless you have actual data like to test, how would you even do a problem?
Yeah. Yeah. So here's where I was going. So if guess is great, so my guess is 7. That's greater than my target of 1. So normally I would look to the left.
Okay.
In a regular binary search, but I have these other 2 checks. Is my guess greater than my max? Yes. Guess at 7 is greater than 2. And is my max greater than my target? Yes. 2 is greater than 1. Therefore, I know that the counter effectively, or the sorted array, must start over somewhere in this section. So I know, so I also know that my value that I'm searching for must be in this section, not in the left-hand side. So anyway, basically that was the logic, and so I had to run it for both the guess less than target and the guess greater than target scenarios by adding those additional two conditionals.
So I think you did a great job of explaining, your thought process and everything. I just want to warn you, or maybe suggest, if you're going to use a helper function, maybe just put helper function in here. You know what I mean? Because you're just trying to almost say in plain English what you're doing. So, yeah, that's the only thing. Like, that's literally the only sort of constructive feedback I have.
Yeah, no, that's good advice.
This is amazing, though. Like, yeah, if you're thinking about it, like, go ahead and put it down. It's just pseudocode. I mean, if you're like, no, that's bad. I mean, and that's the point of pseudocode, is to get you to think through the problem before you actually do the problem, so that you have a roadmap for, if you get a little bit lost or anything.
Yeah.
So,
yeah, sure.
Cool.
All right. Well, thanks.
For doing that.
No, thanks for bearing with me.
Yeah, no problem.
Stop. I'm going to stop the. If I stop sharing, it won't stop recording. Stop recording. Stop sharing.